Hello everyone. In this video, we are going to discuss about combination of capacitors, that is capacitors connected in series of class 12 physics from the chapter 2 electrostatic potential and capacitance. So here you see we are considering two capacitors C1 and C2. Let C1 be the capacitance of the first capacitor and C2 be the capacitance of the second capacitor. Okay, now you see these two capacitors are connected like end to end, that is they are connected in series. Okay, now you see the two ends of the capacitors, no? That is this end and this end that will be connected to a battery here. Okay, that will be connected to a battery here, then only the circuit will become a closed circuit. Now you see the port C, Q is the charge on the first capacitor and the same charge Q is there on the second capacitor. Okay, now you see the total, that is in series combination, charge on each capacitor would be the same. Now, let V1 be the potential difference across the first capacitor and V2 be the potential difference across the second capacitor. Then you see the total potential drop or total potential difference V across the combination of these two capacitors, that will be the sum of potential drops V1 and V2 across C1 and C2 respectively. That is, we can write V is equal to V1 plus V2. Now you see, we have this expression for the capacitance as C is equal to Q by V. Okay, from this expression we can write V is equal to Q by C. So when we consider the series combination of capacitors, let V be the potential difference across the combination and Q is the charge on the capacitor in when they are connected in series, and C is the effective capacitance of the series combination of capacitors. So here we can write this V as Q by C. Okay, okay, see this V can be written as Q by C. This is equal to V1 can be written as what? Q divided by capacitance of the first capacitor plus V2 can be written as what? Q divided by capacitance of the second capacitor. You see, when capacitors are connected in series, the charge across the combination, that will be the same as charge on each capacitor. That is why we are taking Q in all the terms. Okay, instead of taking Q1, Q2, Q3, etc. Now you see, this can be written as Q by C is equal to, I am taking Q outside so that this becomes 1 by C1 plus 1 by C2. Okay, now you see this Q and this Q can be cancelled. That is, if you take this Q to this side, that comes to the denominator, they get cancelled. So that we get 1 by C is equal to 1 by C1 plus 1 by C2. That is, this C is the effective capacitance of the series combination. So when two capacitors are connected in series, their effective capacitance will have this form: 1 by C is equal to 1 by C1 plus 1 by C2. So while we are putting this equation in numerical problems, you will be getting 1 by C using this expression, and at last you have to take the reciprocal of this so that you will get the effective capacitance. Okay, now you see, for n number of capacitors connected in series, the effective capacitance of the series combination of n capacitors becomes 1 by C equals 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4 plus 1 by C5 plus etc. 1 by Cn. So in this video, we have just discussed about the simple topic, capacitors connected in series. I hope it is clear to you. Thank you.